Welcome to the series of lectures about the actual designs for non-experimental quantitative research. We've been talking about descriptive statistics, and now we're going to look a little bit deeper at some research designs that depend on descriptive statistics. So in this series of lectures, I want you to be able to discuss time and age as measurables and how those relate to these descriptive designs that we're looking at, these non-experimental designs, I also want you to be able to describe some non-experimental research designs, some descriptive designs, some comparative designs, and some correlational designs, and be able to understand the differences between those. We're also going to review very briefly survey research because that is a huge part of non-experimental designs. And last of all, I want you to be able to understand how you can use secondary data analysis and do some non-experimental research designs with that. So we'll get started. First of all, let's stop and think a minute about what I'm talking about when I mean experimental or non-experimental designs. The ones we're going to focus on this week are non-experimental. Now, when you're doing a true experiment, look down the left-hand side here. You'll remember from your middle school years in science class that when you're doing an experiment, you have an independent variable which the researcher manipulates or changes the level of, and then you have an experimental group and you have a control group. Remember, in the control group, you didn't change anything. Do you remember the old experiments they used to talk to us about? You know, we're going to add fertilizer to these plants and we're not going to add fertilizer to these plants. So you had a control group of plants and then your IV was the amount of fertilizer. So that's what we're talking about even in educational research with true experiment. You take an experimental group and you take a control group. And you don't take those groups existing. If it's going to truly be experimental research, you randomly select from your sample and then you randomly assign the students or the subjects to each of these groups. When you do that, you can confidently tie that change in the independent variable to your outcome or to your change in the dependent variable. And you can be really confident that the change in the independent variable caused the change in the dependent variable. So let me give you an example of a situation like this. Say I truly wanted to see if an hour of physical education every day helped students reading scores, their reading comprehension scores. So I take a group of third graders and I do a random sample from across maybe 5 schools that I have access to. So I take a random sample of those third graders and then I randomly would assign, you can see the problems with this and how difficult it is to do. Then I would randomly assign those third graders to either an hour of PE every day or physical activity, or I would assign them to the control group, the students who don't get an hour of physical activity a day. Then I would run the intervention, the PE or the physical activity or the not, for a series of time. I would see where the kids were to begin with their reading comprehension, and then at the end I would see if there was any difference between the two groups in their reading comprehension. And if I found that the intervention group had higher reading comprehension scores, and it was statistically significant, I could confidently say that the PE, the physical activity, was a cause for that. Now think about this. I randomly selected the students and then I randomly assigned them. So the group should, all the other factors that could influence their reading comprehension scores were totally randomly selected for. And that's what I would have to do an experiment in education. Well, you can obviously see we don't do that very often. There's just too many reasons, and I'll talk about that in a minute. Now, on the right-hand side of this screen is the non-experimental descriptions. So what we do most often in research for education is that we take existing groups of kids or subjects. So the independent variable is already different in these groups. And then what we can show is we can show a relationship. We can describe a relationship between the independent variable and the dependent variable. So going back to my same example, if I took a school, a group of students in third grade from one school, and they got an hour of physical activity every day as part of their school program, and then I compared them to an existing group of students in another school where they didn't do an hour of physical activity each day, then I could look at the difference in the reading comprehension scores of those two existing groups. And if the group that got the physical activity scored higher, I could say there was a relationship between the amount of physical activity and the reading comprehension. I could not say that the difference in the groups, that the physical activity caused any difference. I can't go to cause with this because they weren't randomly selected. So let's look at some research questions that often use this non-experimental designs. We see a lot of this, both formally and informally, in the education world. So what are some ways parents are involved in schools? You could go in and do a non-experimental study and sample and survey and describe and come up with an answer to that. It would not be an experiment. You could ask if there was a relationship, and this is one that's been asked a lot, is there a relationship between the number of passengers in a vehicle with a teenage driver and the number of accidents? Is there a relationship there? And you would find in the research that there is. There's a really strong relationship between the number of kids in the car with a teen driver and the accidents, the probability of accidents happening. We can't say, though, that the number of passengers caused the accident. How often do teachers give specific and meaningful feedback to students during class? You could do tallies, you could do surveys, you could look at recordings of classes, and you could describe an answer to that and come up with a good description. You could survey what student attitudes are towards having one-to-one devices. Not an experiment. We could look at what percentage of students are in each benchmark group for the state CRTs. None of these are experiments, but we do a lot of these kinds of non-experimental research questions. Well, why don't we experiment a little bit more in education, especially if experimental designs are the ones that let us put forth a cause for an effect that's documented? Well, when we do an experiment, we have to randomly select the control group and an experimental group, and then we manipulate or vary the independent variable to see what happens. And in education, we simply don't do that much. And here's some reasons why. First of all, sometimes we cannot manipulate the variables. So if we've got a group and we want to see what gender, if age causes reading comprehension or something like that, I can't take a group of kids and randomly say you're 6 and you're 7 and you're 8. It doesn't make any sense. So there are variables we simply cannot manipulate. Then there are variables that we should not, that it would be ethically or there would be moral problems with manipulating them. For example, say we wanted to look at the relationship between a good solid breakfast and test scores on testing day. We really ethically could not deprive some children of breakfast so that they could be our control group to see what a difference makes, and randomly select children to go hungry. That's absurd. We also could not select a group and put them in some kind of danger or risk. One of the examples I think of is fetal alcohol, the relationship between alcohol consumption when a woman is pregnant and then danger to the fetus or fetal alcohol syndrome. We would never randomly select pregnant women and assign these ones to alcohol consumption and these ones to not. It's absurd to even consider doing that. And then sometimes it's simply impractical or very, very difficult. There may be political reasons that within the culture of a school or a school district or a study, the cost may be prohibitive, and it may be very, very difficult to break apart natural groupings that exist. So there's a lot of reasons why we don't experiment very much in education. So we use a lot of inherent or what are called organismic variables that already exist, like gender, age, and ethnicity. Those are critical in a lot of what we do to understand what's happening as children learn. So when we look at non-experimental designs, remember that what I'm talking about with research design is that plan and structure that the researcher has to provide some kind of credible answer to the research question, the how they got to the answer of that research question. And so the purpose of non-experimental designs then can be to describe what's happening and what is. It can be to identify relationships that happen among variables. Or very, very often, non-experimental designs help us suggest ways that further investigation can be done or start down a path. Now, time and age are very interesting parts of non-experimental design, but your text went into this, but I don't think it was very particularly clear, so I wanted to address it separately. Time and age designs are any type of design. It could be a survey, it could be correlational, it could be descriptive, it could be quasi-experimental. Time and age don't relate to a type of design, but those designs that focus on changes or differences that are time related. Age is often very important in research design. If I want to describe differences between two groups of children, perhaps describing the differences between a group that has an intervention and one that doesn't, I need to clearly spell out the ages of the children. I wouldn't want to be comparing 8-year-olds to 15-year-olds. I need to be very careful there. And we often want to education takes a while. A lot of the things we do in education are not immediate. We want to see progress over time. So we often want to describe changes that are seen over time. I may want to describe the math reasoning skills of children as they change over the course of a year. So that's what we're talking about with change over time. And when we look at two types of designs and data collection that look at changes in time or changes with age or maturation, there's really two types. There's cross-sectional designs and there's longitudinal designs. Let me talk first about cross-sectional designs. These are very, very common types of designs. You've seen studies of math scores worldwide across different groups, such as the NAEP or the PISA. What they do is they take the data collected at one point in time. We give a test and we collect data across different groups, and then we compare them. We can compare 8th graders to 10th graders to 6th graders. So some examples of cross-sectional designs. Remember, one point in time, but different groups. would be student, teacher, parent opinions about an extended school day. So you've got three obviously different groups. One that relates more to time would be you could look at elementary and secondary teacher years of experience. Is there a difference between the years of experience that most elementary teachers have and secondary teachers have? I really, for example, if I want to look at math scores, math test scores on third, fourth, and fifth grade CRTs, first of all, I'd have to standardize them. We talked about that before because the tests are different. So I'm going to standardize them so that I can confidently use z-scores to describe look at the math test scores of these third, fourth, and fifth graders. I really cannot confidently say that the difference, say the fifth graders do better on the math test, I can't say it's related to maturation. Because those fifth graders are being compared to existing third graders. All I can say is that they are different. The results are not because of changes over time. Maybe I ask fifth graders and seventh graders about their sense of belonging and find out that fifth graders have a stronger sense of belonging than seventh graders do. I can't infer that that is because of their age. Perhaps the seventh grade zoning just changed and the students feel really disconnected because of that or some other thing. So when we're doing cross-sectional studies, we have to be very careful. We're comparing different groups at one point in time and showing the differences between those groups. For some reason, we want to see the difference between third grade, fourth grade, and fifth grade. And so we would do a cross-sectional design. Now, longitudinal designs are, let me back up a little minute. First, in cross-sectional designs, you have to be very careful with some specific concerns. The biggest one is, do the groups you've chosen really represent the sample that you've got or the participants within that group? Do they, before you can generalize out? So you need to worry about sample size and different things like that. And in a cross-sectional design, you've always got to be thinking about the effects of other variables that you're not looking at or considering other than age or what makes the group a group, the differences between them. Now, longitudinal designs are different than cross-sectional designs. When we really want to describe true changes over time, we do longitudinal studies. And then we take a look at the same people or groups at different points in time. And so some examples, we could have a yearly survey of the sense of belonging, and we could give it to children when they're in fifth grade. Then the next year we'd give it to them as sixth grade, and then the next year we'd give it to them in seventh grade, and so on, all the way through 12th grade. And that would be a longitudinal design, and we could actually see changes over time. There are three types. Trend studies use the same type of group year after year. So one example would be 10th graders and drug use. Each year we survey the group that is in 10th grade, and we get samples each year from the 10th graders. And then we're able to see a trend over time of over time, does it change? Does the group we're calling 10th grade change in their drug use over time? A cohort study means that we've got a group and we follow that group year after year. So we would survey them in sixth grade, then we'd survey them in seventh grade, and we'd survey them in eighth grade. So compare that to the trend study. A panel study is not as common because with a panel study, you take a group of people and you use that exact group of people each time you make the measurement. So you can imagine how difficult that can be. So think about the difference between asking fifth graders and seventh graders about their sense of belonging. That would be cross-sectional. Now imagine that you asked the fifth grade class in 2012. Then you ask them again when they are seventh graders in 2014. That would be a longitudinal cohort design. So I found that it sometimes helps to understand the differences between designs by kind of lining them up on the questions that you'd ask. So let's go through this. Cross-sectional designs. When you look at your sample for cross-sectional designs, you're looking at 2 or more groups, and at time, 1 point in time. Now look over in the longitudinal design column. There your sample is 1 group, and you're looking at that group at several points in time. So some examples. In a cross-sectional design, I could develop a drug use survey for 6th graders, 8th graders, and 10th graders and answer the question, how does the drug use of teens differ among these different age groups? 1 point in time, 3 different groups. If I were to do a longitudinal design, still trying to get at drug use information, I could do a trend analysis. So I would survey the 10th graders in 2000, then I'd survey 10th graders in 2005, then I'd survey 10th graders in 2010, and then again in 2015. And then I could answer the kind of question, how has drug use among 10th graders changed over 15 years? If I wanted to do a cohort analysis, I could do a drug use survey of 6th graders, then repeat that when they are 8th graders, and repeat it when they are 10th graders. And then I could answer a question like, how does drug use change as teens get older? Now, if I wanted to go to the work of doing a panel analysis, I would do a drug use survey of 30 6th graders. And then the same 30 students, I'd repeat it when they're 8th graders. And I would repeat it with those same 30 kids wherever they went to in the world when they're 10th graders. And then I could answer the question, how did drug use change in this sample as teens got older? So you can see the concerns that come up with that. I talked about these earlier. In longitudinal designs, you have the same 2 concerns as cross-sectional design, but you also have to add 2 more. Attrition means you're losing people. For example, the hardest one, of course, is a panel study. People drop out and they get sick. They pass away sometimes. They become unavailable. So that's what we call attrition, and it happens with a cohort. Also, and you can see why people tend to do trend analyses. But with a cohort, you've got to accept that some kids will come and some kids will go with that cohort group when you repeatedly go back and test them. And then tracking the subjects can be really, really difficult, especially if you try to do a panel analysis. Now, descriptive designs are really just designed to tell what is or describe a phenomena. So you often hear phrases like paint a picture or tell a story, but to do that, you're using descriptive statistics. Yeah, those things. Remember when I talked about the measures of central tendency and graphical representations? You're using those to describe what is. And this becomes really, really important as the first stages, especially when we're opening a new area of study or there's a new intervention that could be researched or something like that, a new way to do things. Descriptive designs are really, really important for us then. So when you're critiquing a research design that is simply describing what is, you're going to be looking at all those descriptive statistics and how they're being used. And you need to look for a couple of things. First of all, the researcher has nothing on which to base inferences. You have to be very, very careful about that. There can be no influences about the relationships because all you're doing is describing what is, not the relationships between them. You need to be able to see a really complete description of the participants, the instruments and the procedures that were involved with gathering the information. Conclusions from descriptive research are simply really not there. It's very hard to pull conclusions out of something that where you're just describing it. You should never be the conclusions from a descriptive research study should never drive policy or be used for decisions, although it's amazing how often they are in our world. In a descriptive research study, there's no answer to the why, but describing what is can lead you to investigate further and figure out the why. So that's kind of wrapping up on simply descriptive research studies, and there are a lot of them out there.